This is ME2110 Section A07 Group 4, otherwise known as the Dyl Pickles, proudly presenting our robot, Rick. During this semester, our team was tasked with creating a fully functional robot to participate in the Fall 2020 ME2110 competition. This project encompassed many of the important facets of the real-world engineering process, such as problem-solving, brainstorming, designing, testing, and improving. Throughout these past few weeks, our team has learned the importance of productivity, communication, and teamwork in order to effectively design, manufacture, and assemble a robot capable of performing all of the necessary operations for success in this course.
This robot was designed to perform specific operations laid out by ME2110. These included the launching of archery balls into a specific target, the acquisition of a bonus point money ball, and the scoring of said money ball and basketballs into another target area. Our team began by prioritizing these required tasks. We implemented a house of quality to help quantify the various different functions and engineering requirements necessary for the development of the final product, allowing us to quantitatively rank our needs in order of importance. We developed a specification sheet to help with the breakdown of different components required for the final product, which helped to compartmentalize workload between team members for clearer understanding, and a function tree that helped to indicate the necessary functions for each of the design components. We decided to focus most of our initial design efforts on the money ball and basketball portions, as they would provide more overall points. We created a morphological chart that helped with the design process, allowing us to visualize and combine different possible mechanisms that could achieve the task set before us. We used 4 morphological charts to parse through design alternatives. In the chart for Alternative 1, we drafted a motorized flywheel to hit balls in archery and a motorized pulley slide system to extend the basketballs and release them with a pneumatic flap. For Alternative 3, the archery design used a mousetrap releasing mechanism with a solenoid to hit balls and drove the whole robot to the cups and used a pneumatic release flap to drop the basketballs. For Alternative 4, a pneumatic pusher would hit the balls in archery and use a slide system with a motorized roller to push out the basketballs. But Alternative 2 won out with its motor-released mousetrap for archery and slide system along with its solenoid release flap for basketball. We created an evaluation matrix for both archery and basketball. For archery, after running test shots with prototype shooting mechanisms, Alternative 2 notably earned max relative scores of 10 in both distance and accuracy. For basketball, after testing the motor speeds when pushing different weights, Alternative 2 notably earned the highest runtime score of 8 as the light solenoid release system could be pushed the fastest. Our engineering team used several different conceptualization tools to help with the design process, including Procreate, Inkscape, GrabCAD, and a lot of SolidWorks. For fabrication, we took advantage of automated systems such as laser cutting and 3D printing to ensure that all our parts were created exactly as designed. Due to lack of time management, most of the fabrication and testing for Sprint 1 was conducted in one build session the night before the sprint. The bulk of the work was centered around finishing the chassis and perfecting the basketball mechanism. However, we were unable to create a working money ball retrieval system in time for the sprint. The attempt for return points was also forfeited during this process, as the gear ratio for the motor and linear rails would not allow for a full extension and retraction within the allotted time of 1 minute. Focus on perfecting the archery mechanism was also sacrificed for the first sprint, as in order to fix the range, we would need to resin print and test levers at varying lengths. Instead, our team opted for a quick fix solution and added a few layers of electrical tape on the surface of the hammer that contacts the ball. This lowers the range of the mechanism, but the accuracy and precision of the landing positions were too variable. Our performance during Sprint 1 was an accurate representation of the work that was done. As expected, most of the archery balls landed outside of the target area. The basketball stock items were all delivered to the center cup, except for the trial where the cups were placed the farthest away. This was due to the inability for the rails to fully extend to that length. The money ball was not picked up during any of the trials. With most of the points from the basketball event, we were able to score a grand total of 800 points.
Since our team was generally happy with our performance in Sprint 1, any fabrication done for Sprint 2 was focused on refining the mechanisms. For basketball, retrieving the money ball became a top priority, and the scooper arms were extended to solve this problem. This alteration made collecting the money ball a consistent event. For archery, the lever arm was replaced with a shorter one that allowed the hammer to slip earlier, thus decreasing the firing distance of the shooting mechanism. We exhibited a much better performance in Sprint 2 due to the acquisition of the money ball and increased accuracy of the archery shots, almost double our Sprint 1 total with a cumulative score of 1530. These two sprint results placed us at second in overall power rankings throughout all of the ME2110 sections, which we were very happy with. However, even with our increased performance, our robot still exhibited failure points on some trials that limited the amount of points we could score, which our team worked to improve on in the week leading up to the final competition. Our robot was unable to extend to the furthest position for basketball, resulting in our team scoring one cup from the center. Additionally, our archery shots were rather inconsistent, with only 3 of the balls scoring in cups and the others bouncing off the rims. To account for these shortcomings, our team decided to print a tighter tunnel for our archery mechanism to prevent side-to-side motion, and changed the drop angle of the basketball holder so that the balls would roll out further, allowing us to score into the center target on the furthest position. Moving from Sprint 2 to the final competition, our team continued to alter small mechanisms in order to perform better for the last group of trials. This included the minor changes to the basketball and archery mechanisms to help with consistency and scoring explained before. Our final chassis remained the same as the first 2 sprints, the sturdiness and reliability of the 2x4 frame more than enough to last through the semester. We added friction pads on the bottom of the frame to prevent slipping, which helped our basketball mechanism remain straight when extending outwards. The archery mechanism was modified a little bit from Sprint 2, but the concept remained the same. A double-barreled archery ball holder acts as the housing for both balls, and a lever-activated mousetrap hammer fires the arrows with a consistent elastic force to allow for consistent initial motion of the ball on impact. The basketball mechanism remained mostly the same from Sprint 2, with the only change being a stopper that prevented the scooping arms from hinging too far down. This would allow for the basketballs to roll further outwards upon release, which helps with reaching the furthest basketball goal. Our team hopes to improve our score in the archery section specifically, since that was where we lacked points the most. We plan to be able to score both balls into the green or yellow sections consistently, allowing us to raise our archery score by 100 to 150 points.
Throughout this semester, our team continued to improve not only our engineering capabilities, but our teamwork, communication, and time management skills as well. Together, we built each other up into better engineers and team members. We hope you enjoyed this semester and our final presentation video. Thank you!